Assalamualaikum. In this session, we will continue about the problems and how to solve the organic spectroscopic data. We comes into problem 3, where the spectra have been given from different spectroscopy. In this case, the given data is from the MS, FTIR, carbon-13 and proton. Based on all the spectra, the question asks us how to elucidate the structure. Based on this, I always prefer to interpret the FTIR data first, whereas in this case, the typical signal, the important part is the presence of carbonyl group. Others, all the organic compound, we have this stretch, CH and CC stretch. And you can write down in sentence, or you can make it in the table like this. And next, I will go for the interpretation of the proton NMR. There are 4 signals with different multiplicity and integral. All this data must inform us this table. We have to write down this table, which is 4 columns. Before we go for the assignment, all this data you can get from the NMR spectrum. 0.9, triplet 3, 1.6 hextet 2, 2.2 singlet 3, 2.4 triplet 2. All this data is the raw data from the NMR spectrum. Based on this, we go to the assignment one by one. Let's see. 0.9. 0.9 is the region of what I already mentioned from previous lesson, which is there are 3 typical signals for the hydrocarbon, which is methyl, methylene, and methane. This region should be memorized, which is the region for 0.9 is the methyl region for chemical shift. And the triplet multiplicity tell us that there are a number of 2 hydrogen atom, because the rules of multiplicity is n plus 1 rules. So 2 plus 1 become 3. So the multiplicity of this signal become triplet. And this signal, number of this signal is 2 proton. And integral for this signal is 3. Means this signal itself have 3 hydrogen. That's why our assignment will be CH2 pair with 2H. This how come it come from this data. And or you can write down CH3 coupled with CH2. And one next information is 1.6. 1.6 is for in methylene group. What is methylene group? Is CH2. CH2 with the correction here. This is a pentat 5 signal. 5 signal is for hextet 6 signal. So it means tell us what? It means it's telling us that have 5 of neighboring proton. And integral is 2. It means itself signal is CH2 coupled with 5H or pair with 5H. And next signal is 2.2 is singlet. Means this CH2 is isolated proton, and integral is 3. It means this is CH3. The assignment will be isolated CH3. Why is this CH3 become more downfield? It might be attached to electronegative atom. And the next signal is 2.4. The multiplicity is triplet. It means what? It coupled with the CH2. 2.4 is the region for CH2. And we see whether it is correct or not, CH2. So yes, because the integral is 2, so CH2 pair with the 2CH or couple with CH2. Based on all the piece of information here, CH3 beside CH3 is CH2, and beside this CH2 is CH2. So this is one part, and this isolated is another part, which is in the middle will be the electronegative atom. How we know the presence of C double bond O based on the FTIR data. Based on this, we check whether the chemical shift is correct and multiplicity is correct. Okay, 0.9, yes, correct, because this is a more de-shielded, it's a glass in the ring, and this one is 1.6, yes, correct. Multiplicity will be 5H, is it? Yes. So, correct. And this one CH2, multiplicity will be triplet, 2.4, correct? Yes. And this 2.2 is only singlet. All correct and match with the table, so the answer is here. We get the clue of this structure. After getting the clue, then we can go for the next spectroscopic, which is carbon-13. We know that we have 2 of CH3 carbon and 2 of CH2 carbon and 1 carbonyl carbon. As I mentioned, the region for the carbonyl is always 180 to 200 and above part per million of chemical shift. That's why if you can see the bigger number like this, 180, 200, 210, all this one is for carbonyl, so easily recognized for carbonyl carbon. This one is carbonyl carbon. This one will fall between below than 20 ppm become a methyl group, and this one is methylene group, and this one might be sometimes in the appendix provide you this region 40 to 50, 60 is region for C double bond C. In this case, we predict there are no this C double bond C, so they might be the CH2 direct attached to the C double bond O. That's why after we interpret, we can get this value. 18 is for CH3, 54 for CH2, 22 is for CH3 direct attached to the CO, that's why it's more than 20, and this 50 is CH2. Normally CH2 is around 20 to 30. That's why it become more downfield because it direct attached to the C double bond O. This C double bond O easily recognized with the value more than 180 part per million. That's the assignment for C13. Now we come across with the MS data. MS data, just you can calculate down the molecular weight, whether it's mixed with the 86 like previous example, or you can make a fragmentation pattern in details for each of the cation. In this case, when it fermentized here, it lost here this part, it become this ion MZ71. When it lost this part, it become this cation, the most stable. So you can see this is confirmed, the structure is correct. Rather than that, rather than interpret the fragmentation pattern for the molecular structure, we also can calculate the DBE. DBE on the structure we write down there is 65H10O. So we check whether DBE is correct. DBE should be 1 because they are 1 double bond C double bond O. So the answer is correct. So confirm the structure is the one that we are looking for. And next, we also can calculate the molecular formula based on the molecular weight and the rules of, we use the rules of 13 if we know the molecular formula. Then confirm the structure, the molecular formula is correct based on our structure. Now the answer is all the spectroscopic data match each other and the structure will be confirmed. Next problem will be problem 4 in form of text. They can be in form of spectrum or in form of text. We read the question. An organic compound with molecular weight 120 absorb UV-VIS 268 nanometer. Emax 480. We don't know what is it. Okay, just ignore first. In infrared, there are signal like this. All this one, we see that the trend of 1617 is the presence of C double bond C. The NMR spectrum shows this singlet. Is it correct or prediction? Because I said the region around 6 to 8 is always for the 6 to 8 is always for the presence of aromatic ring, and 2.26 is the region for the CH2. Is it correct? We have to go in details one by one for the interpretation. We have to draw the table for the proton NMR, and then we can separate this one IR, and next we go for the MZ value to confirm the structure. And based on this 6.7879, we know they have a 3H. Is it in the aromatic ring? Yes. CH3 is shielded. This CH3 is from the aromatic ring 1, 2, 3. Singlet because there are no neighboring proton. That's why the integral is 3H. So this is not CH3, this is CH. Correction. CH is de-shielded. All this H in aromatic proton. And 2.26 is singlet. Singlets means 9H, means there are 3 groups of CH3. And in this structure, we can see these 3 groups of CH3, and this is the single CH. And after we interpret, as just mentioned just now, the FTR are telling us the presence of C double bond C, and this is how interpret the IR. And the UV-VIS is the lambda max is go for the further more nanometers, so it shows us the presence of unsaturation conjugation there. So the structure will be like this one, confirmed back or with all the data and in mesh, and the structure have been confirmed. That's all for the example of 4 problems. Thank you.